Okay, let's take a look. As soon as I get my wires out of the way. There we go. In a 60-60-60 triangle, show why sine 30 is 1/2. Okay. This is 60 degrees. This up here would be 60 degrees. And this over here will be 60 degrees. Now, if all of these are the same, then this distance here is x, this distance here is x, and this entire distance here is x. Now, if I split this up, if I split that up, this will be 30, and this will be 30. Now, this distance right here now becomes half of x, because all the way across is x. Then it says sine 30 degrees. Well, sine is equal to opposite over hypotenuse. So opposite, and again the angle we're looking at is this 30 degrees right here. So the opposite side will be over here, and our hypotenuse is right here. So opposite would be 1/2 x, and our hypotenuse is x, and you see the x's cancel and gives us 1/2. Okay, that was our first one. Our second one. I probably won't convert all of those maybe, but here's pi. You want to convert it to degrees. Well, this is pi radians. I'll put RAD for radians. And this is dimensional analysis. You put it over 1. Now, if I got radians up here, then I have to put radians down here. Now, all the way around our unit circle is 2 pi. And that's equal to 360 degrees. But if I go halfway, that's 180 degrees, or pi. So I'm going to put pi radians here, and 180 degrees here. Now, whatever unit measure is up here is automatically what you want to put down here. Now, since they're the same, those radians cancel, and also the pi's cancel too. So we'd have 180 degrees. Let's see, 3 pi. And I'll put the RAD there just to really emphasize it. And whatever unit measure you have here automatically goes down here. And we've already said pi radians is equal to 180 degrees. So radians cancel there. The pi's cancel. And I got 3 times 180. 540 degrees, I believe. And then negative pi over 4. Radians, I put over 1. And again, we'll put radians down here. And then degrees goes up here. So this radians cancels with this radians. As bizarre as it seems, this pi here cancels this pi. And we're left with negative 1/4 times 180 degrees. Negative, and then that divided by 4 gives us negative 45 degrees. And then it says go in the other direction. Go start with 60. Again, dimension analysis, put over 1. And if degrees is up here, then degrees has to be down here. So we'll put 180 degrees here, and we'll put 1 radian here. Degrees cancel. And we got 60 over 180 radians. And that gives us 1/3. Now, typically you don't actually put the radians on there. I just put it to really emphasize it. One more of those. 90. You got to put over 1. And if degrees is up here, then degrees has to be down here. So I have 180 degrees equal to 1 radian. The degree symbols will cancel. And I have 90 over 180 radians, which gives us 1/2. And so on. Now they also ask, what angles between 0 and 2 pi correspond to theta is equal to 480 degrees? Well, our unit circle is from 0 to 360. So we'd have to subtract 360. And the angle that corresponds to 180 is 400 or 120. And then -1 degrees. -1 isn't on our unit circle, so we have to add 360. And that gives us 359 degrees. And that would be, so it's not our unit circle. I guess it doesn't say that. Oh, and it does say what angles between 0 and 2 pi. That would almost imply that they want you to change those to radians, which is what we just did up above. So you see how to convert that. Okay, number 3. Draw graphs of tangent and cotangent from 0. What is their shortest period? Not just in general. I won't do cotangent, but I'll do tangent. Okay. Okay, so I put it in this notation. Y is equal to tangent theta. Our period is equal to pi over b. So it'll be pi over 1 or pi. And then I'm going to put my angle down here, which is going to correspond to our x value. And then we got y is equal to tangent theta. Now this will be 0, so that's 0. And this down here will be pi. That's our period. Exactly in the middle will be 1/2 times our period, which would be 1/2 times pi, or pi over 2. Here will be 1/4 of our period, which will be 1/4 times pi, or pi over 4. And this will be 3/4 of our period. So we got 3/4 times pi, or 3 pi over 4. Now if you plug those into your formula here, you get y is equal to tangent 0 and tangent is equal to sine over cosine. So I have sine 0 over cosine 0. Now if I look up sine 0 on my unit circle, that's this point right here, then it'd be equal to 0. And cosine of 0 is 1. So that gives us 0. And if I got y is equal to tangent pi over 4, pi over 4 is square root of 2 over 2 and square root of 2 over 2. And so this becomes sine of pi over 4 over cosine of pi over 4. So we got square root of 2 over 2 over square root of 2 over 2, which gives us 1. And here I got y is equal to tangent pi over 2, which would be sine pi over 2 over cosine pi over 2. Well, here's pi over 2. And sine is equal to 1 and cosine is equal to 0, so this is undefined. And we got y is equal to tangent 3 pi over 4. And that's going to equal to sine 3 pi over 4 over cosine 3 pi over 4. which is right over here, which will be negative square root of 2 over 2 and square root of 2 over 2. Now sine is going to be square root of 2 over 2, and cosine is negative square root of 2 over 2, which gives us negative 1. And then this goes back to 0 if I were to plug pi in. The idea of a period is it returns back to its original value. Well, our x values go from 0 to pi. Now here's pi, and that's approximately 3. And then here's pi over 2, pi over 4, and 3 pi over 4. Now if that distance is 3, about a third of the way over would be 1. So more or less, I'll put a 1 here, and I'll put a negative 1 down here. Now my first point is 0, 0, right there. Next one's pi over 4 and 1, right there. And it's undefined at pi over 2. And then 3 pi over 4 is negative 1, down here. And pi is 0. And what I'm going to see is that since this pattern repeats, then the next one would be about right there. And then the next one over to here would be undefined. So then if I draw that, I don't draw them very well. You can look in the book and see a little bit better picture. That'll give us our graph. And same thing over here. It has something like that, and this would be undefined again. Now you do the same thing for cotangent, but instead of opening up in this manner, they open like this. But it's the exact same idea. So that's how you graph that. What is our shortest period? What's pi? I'm not sure what they mean by that. Unless they're wanting you to derive pi. Now it changes when you have other numbers in here, but just have tangent and it's always, period is always pi. And by graphing it, you can see that. After pi units, it starts repeating.